Good day, everyone. Welcome to Learn at Home live tutorial session. I am Mr. Odunlami. It's good to be back online this new year. I'll be taking you through coordinate geometry of straight lines. And here in today's session, majorly we are basing our work today on geometry, which is particularly gradients of a straight line. And then we're going to discuss the lesson in full. We'll go on a quick break. During the break, you're expected to type in your question, and after the break, we're going to answer the questions. Anything you have, just put them in the bottom, in the forum. And after that, we'll go to the closing session. So let's hit the ground running. We shall learn to represent points on a Cartesian plane. We shall also learn to find the gradient of a straight line with specific formulas. We have about 3 formulas we're supposed to use, and then we shall find the gradient of any straight line from the particular equation given from the question. Okay, so quickly, what is coordinate geometry of straight line? Any straight line has an equation in the form y equals mx plus c, where the m represents the gradient and then the c represents the intersect with the y-axis. Okay, so this is what we're trying to say. This is the Cartesian plane. Cartesian plane represents the x-axis and then the y-axis. Together, it forms the Cartesian plane. Okay, so we are saying when we have a straight line, the point of intersection with the y-axis is called the y-intercept, which is c, and then the slopiness of the line is called the gradient, which is m. And we can also see this kind of line is a positive gradient, and that's why it is rising. There are some lines that fall. So those kind of lines that fall are called negative gradients. An example is this. This falling line has a gradient, and the gradient is negative. So we call this the negative gradient. So in a way, how I see gradient is just the difficulty level in climbing a hill, like a mountain, staircase, and things like that. And so moving on, still on the coordinate geometry and still working on the Cartesian plane, we're going to learn to locate points on the Cartesian plane. We have this point, as you can see, point A, which is actually 20, 15. What it means is the value on the x-axis is 20, and then the value on the y-axis is 15. Usually, we make the x come first and the y come next. X before the y, horizontal first before the vertical. And so, when we are representing points, we put it in brackets like this, and all together we call it coordinates. And that's where the coordinate geometry comes from. Now, let's assume that we want to pick another point. This is negative 20. Let's call this a point B. And below, this is going to be negative 15. So we are picking the x-axis first, that's minus 20, and then minus 15. This will give us another point, which is now the second point. So this is a simple way to locate any point on the plane surface. We can join these 2 points together. We can join many more points together, which will now bring us to coordinate geometry. Okay, so now we're going to specifically talk about gradients in this course. And I want you to take note. This point here altogether is called coordinates. The x value is called the abscissa, x before the y. The x value is called the abscissa. Let me write that in red. Abscissa. And then the y value is called the ordinate. You may not be requested to write this down anyway, but it's good if you can take note of some of these things. The abscissa and the ordinates. These are some of the things we call and altogether we call them the coordinates. Okay, so moving on straight into the gradient of a straight line. We can now say the gradient of a straight line is defined in 3 equations. M is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. This is the first equation we are going to use to find gradients. The second equation is y equals mx plus c. This is the general form. And then finally, we can say m is equal to tan theta. Theta, obviously, is the Greek symbol we always use for angles. Okay, now the theta is the angle made with the positive x-axis. Angle made with the positive x-axis. Please take note of this, because sometimes questions will come in different pattern just to confuse you, just to know if you actually know what you're doing. And so sometimes they will say the value of theta is so to the negative x-axis. You are meant to convert back to the positive x-axis, and we are going to use exactly that. All right? Okay, so using these 3 definitions, we are going to find the gradient of straight lines. Let's deal with the first one, which is y equals mx plus c. Given the following straight lines, find their gradients. Number 1, y is equal to 2x minus 3. Y equals 2x minus 3. Okay, that's a simple equation. Two x minus 3. All right. Now, recall that the general form of a straight line is y is equal to mx plus c. And I said beforehand, m is the gradient. Okay, so all we need to do is compare these 2 formulas. By the time we compare these 2 formulas, we can see obviously that 2 is a number representing m in the equation. And so we can just say m is equal to 2. It's as simple as it looks. Okay, so let's solve another example. Example 2. 2x minus y plus 1 equals 0. 2x minus y plus 1 equals 0. Okay. Now, the solution can be seen, but let's go through the solution step by step. Since from the general form of a straight line, we can see that y is the subject of formula. We are going to do exactly the same thing. Exactly the same thing. We are making y the subject of formula here. If we bring y to the other side, it becomes positive and it becomes the subject of formula. So simply 2x plus 1 is equal to y. Y is already the subject of formula. And we can easily say y equals 2x plus 1. These two equations are exactly the same. Okay, so comparing this equation with what we were given before, we can see that the gradient is 2, which is the number standing beside the x, and we call it the coefficient of x. The coefficient of x, and we can just say the gradient m is equal to 2. Very simple. Let's do one more example, just for clarity purpose, and then we'll move on to the next. Okay, the third problem, 2x plus 3y minus 3 plus 3y minus 3 equals 4. Okay, and like I said, since we're comparing with this general form of a straight line, y equals mx plus c, we are going to make y the subject of formula. This is y. To make y the subject of formula, we'll pick all the other numbers to the other side, one after the other. Let's deal with the 3 first. So this will give us 2x plus 3y equals 4 plus 3. 4 plus 3 is 7. And so we can say 2x plus 3y equals 7. Y is still not the subject yet. We still have 2x disturbing the y. So we can move 2x to the other side. 7 minus 2x. Okay? We're almost there. Remains the 3. At this point, we will divide all two. By 3, which is the last number remaining, is equal to 7 minus 2x. If we divide both sides by 3, we'll finally get, of course, the 3 will cross out the 3, we'll be left with y okay. After dividing both sides by 3, we'll be left with, let me continue on this part. We'll be left with y equals 7 minus 2x all over 3. Okay, now from our simple knowledge of splitting of fractions, we can say this is the same thing as 7 over 3 minus 2 over 3x. 2x over 3 and 2 over 3x are exactly the same thing. 2x over 3 and 2 over 3x. They are exactly the same thing. What this means is you are multiplying 2 over 3 by x. And what this means is just the same thing. So, instead of writing 2x over 3, you can write 2 over 3x, so that it is very clear that the coefficient of x here is minus 2 over 3. Always remember, we are comparing with the equation y equals mx plus c. And so, m is the coefficient of x. We can finally say the gradient of this line is equal to minus 2 over 3. Quite easily done. It is easier than it actually looks. Okay, so this is the first way to find the gradient of any straight line. All right, now let's move to the second pattern. We're given another formula which states that m is equal to tan theta. And I said theta is the angle made with the positive x-axis. Okay, now recall that the question says, okay, this is going to be example 4. Recall that the question says, find the gradient of the line which crosses the x-axis at 60 degrees. Okay, as soon as you see the angle there, you automatically know that you need to deal with the equation that has the angle. Okay, so the gradient will just be given by tan 60 degrees. And we can use a calculator, we can use a 4-figure table to solve this problem. Tan 60 is root 3. And so if you prefer your answer to be in surd form, you leave it like this. If you like your answer to be in decimal, this is the same thing as 1.7321 to 4 decimal places. Okay, so usually it is okay to know both of them. It's okay to know it in surd form because some OBJ questions, you won't see decimal numbers. You only see fractions and surd forms. Okay, so that is how easy it is. All right, I think we should solve one more problem on this. If, for example, you're told to find the gradient of the line with angle 45 degrees, all you need to do is m is equal to tan 45. And tan 45 is equal to 1, so the gradient is equal to 1. Very simple. Okay, so now let's go on to the final formula, which have to do with the rise over run. Example 5. Okay. Given the following pairs of points, find the gradient of the line joining each pair. All right. Now, we're given 2 points. The first point is 2, 7, and the second point is 1, 7. All right. Now, to find the gradient, we use the formula y2 minus y1 divided by x2 over x1. And so, we recall that m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. I like to call this rise over run. I call it rise because it is the y-axis. It is the y-axis. Okay? So, the run is the x-axis. So if you know that the y-axis is vertical, you know that that is rise. I know that the x-axis is moving horizontally, that is the run. Okay, so to solve the first problem, we have m is y sub 2 is 7. So you have 7 minus y sub 1 is 7 also. 7 minus 7 all over x sub 2 is 1 from the given equation, and then x sub 1 is 2. So, easily, by simplification, we have 0 divided by minus 1, because 1 minus 2 is actually minus 1. Okay, the final answer will give us 0. Of course, 0 is a neutral number. There is nothing like plus 0 or minus 0. It's a neutral number. And so, the gradient of this line is 0. And what this means is that the line is actually horizontal. There is no difficulty. Like I said, I look at gradients as the difficulty in moving up a slope. Okay? If there's no difficulty, it means that the line is actually straight and I just move with ease. All right. So, let's solve one more question on this. Rise over run. Always remember, gradient is rise over run. Example 6. We are looking for the gradient of the line joining point 3, 5 and the second point 5, 11. 3, 5 and 5 minus 11. Okay, now recall the formula. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I always prefer you write the formulas every time. If you are solving 1,000 problems, you write the formula 1,000 times. This helps us to get used and form a filial relationship with every formula we are using. And usually, we don't forget them easily. You can go 2, 3, 4, 5 years without going back to it and still not forget. So it's good to solve problems writing the formulas first. Usually, they award marks for that anyway. Okay, so since we have these 2 points, let's label them. Let's call this x sub 1. Let's call this y sub 1. The subscript there is only telling us that this is the first point and then this is the second point. X sub 1, y sub 1. This is the first point. X sub 2, y sub 2. This is the second point. Every point always have the x and the y axis. Okay, so from this now, it is very, very easy to substitute our answers, or rather our values. So the gradient will give us y sub 2, which is minus 11, minus, this formula has the minus, so we use it. Then y sub 1 is equal to 5 all over x sub 2, which is 5, minus x sub 1, which is 3, minus 16 divided by 2. And minus 16 divided by 2 is equal to minus 8. So we can finally say our gradient m is equal to minus 8. That's the final answer. Negative gradient. Like I said, it means the line is going downwards. It's going downwards. The gradient is negative. So it will be slanting downwards. This is how easy it is. We're going to have simple problems to solve. These are the major things that you'll be dealing with in gradients of any straight line. And so, we'll be going on a short break now. Do well to answer or put your questions through on the forum. It will be answered shortly after the short break. Thank you for joining us. The short break. Welcome back. Okay, I want to quickly give a summary of what I have said before I answer your questions, and then there's an assessment question. There's an assessment question to be solved. All right? Now, to recap all I've said, this is what we call the Cartesian plane. When a straight line moves up, you say a straight line moves up when it goes from down and it goes up from the left to right. Okay? This kind of line has a gradient that is positive. It has a positive gradient. Or, like I said, also called the slope. Okay? When we have another line that goes down, it is called negative gradient. This is a positive gradient. We could have another line that is going downwards in this pattern. It could be on the positive, it could be on the negative, but it's going downwards. So this kind of gradient is what we call the negative gradient. This is the negative gradient. And then there are two others. We have the zero gradient. Like in one of the questions we solved, we had the final answer to be 0. If a gradient is parallel to the x-axis, something like this, it's a zero gradient. So we call this zero gradient. Okay, and then finally, we have one more. There's another type of gradient which is undefined. It is undefined. Why? Because it is parallel to the y-axis. It could be parallel to the y-axis to the right or parallel to the y-axis to the left. But this is undefined gradient. Undefined. We all know that when we have a value, for instance, 0/3, we all know that the answer is equal to 0. And of course, that's why we had the zero gradient. But what if we have 0 in the denominator? Instead of 0/3, we add 3/0. What are we going to get? The answer is going to be infinity, which we also call undefined. And that's why this kind of line is an undefined gradient. And in case you don't know, from now on, don't say 4/0 is equal to 0, because it's actually not equal to 0. It's actually equal to infinity, or you say it is undefined. The sleeping 8, which is also called the lemniscate, is what we call undefined. So these are the type of gradients that we've talked about today. Okay, now there are some assessment questions that I would like us to solve. Quickly, before I take your questions, if you have any. Find the gradient of the line which crosses the x-axis at 30 degrees. Find the gradient of the line which crosses the x-axis at 30 degrees. M is equal to, this automatically tells us what formula we use. As soon as you see the angle there, then you know that this is the formula we use. As long as you see a straight line and you're looking for the gradient, you know you use the y equals mx plus c. As long as you see 2 points and you're told to find the gradient, you know you use the gradient formula, which is the y/1, or the y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay, so from the question asked, the gradient is equal to tan theta, where I said theta is the angle made with the positive x-axis. Theta is the angle made with the positive x-axis. Now they give us theta as 30 degrees. And so, simply, our gradient will be equal to tan 30 degrees. Punch it on your calculator or use your 4-figure table. Tan 30 is equal to root 3 divided by 3. This is in third form of fraction. And this in decimal is actually equal to 0.5774 to 4 decimal places. Because your 4-figure table will give you this to 4 decimal places. Let's stop at 4 decimal places. So instead of writing equal to, let me write approximately equal to, because this is not the full answer. It adds more. It's 57735. So let's just stop at 5774. So this is the gradient of the line. It's as simple as that. Okay, let's solve 2 more problems. Number 2. The question says, find the gradient of the line 3x minus 4y equals 16. 3x minus 4y equals 16. Okay, what formula comes to your mind immediately you see this? The gradient intercept, which is y equals mx plus c. This is the formula that comes straight to your mind. And what do? Of course, you make the subject of formula y. Now, to make y the subject of formula, all you need to do is leave this on this side. So we have minus 4y equals 16 minus 3x. That's the first step. If you're taking the 3x to the other side, it becomes negative. Of course, 16 remains the same because it's not moving. All right. Now at this point, we are almost to, but there's a coefficient of y here, and there's no coefficient of y here. So we have to make it exactly look like this. Divide all through by negative 4. And so dividing all through by negative 4 will give us, I need to write the question first, then I apply my division. If you divide by negative 4 here crosses out the negative 4. And so we can say that y is equal to, this is going to give us 16 over negative 4 plus minus 3x over negative 4. Okay, so to rewrite this equation now, 4 in 16 is 4. 4 in 4 is 1. 4 cannot go in 3 without remainder. So all we need to do is cross out the negative signs. Minus divided by minus is plus. Okay, so finally I can write y equals 4. Okay, sorry, there's a negative sign in the denominator, and plus is in the numerator. Plus divided by minus is going to be minus, and so this gives us minus 4. Minus divided by minus has given us plus. So we have minus 4 plus 3 over 4x. And what we just need to do is now say our gradient, pick the coefficient of x. Coefficient of x is 3 over 4. So our gradient is equal to 3 over 4. Voila. Very easy. Very, very easy. Okay, now let's solve the third problem. The third problem says, find the gradient of the line joining points -2, 8, and 6, -5. Let me write it down. -2, 8, and 2, -5. Okay, 6, -5. All right, now, since we have 2 points, all we need to remember is the rise over run formula. Let's label these 2 points. X, Y. Okay, this is XY, this is another XY. This is the first one, so we have X sub 1, Y sub 1, which denotes the first point, and then the second point, X sub 2, Y sub 2, which denotes the second point. We just use this subscript to differentiate the points so that it will be easier for us to work with. Now, the final solution gives us, like I said, writing the formula is very essential. It helps you to remember the formula even long after you've solved the problem, and you'll be able to solve many more problems without racking your brain. So, substituting each value, y sub 2 is -5. So, substituting the values, we're going to have -5 minus y sub 1 is 8 divided by x sub 2 is equal to 6. Okay, so we have 6 minus x sub 1 is actually equal to -2. Okay, so what do? We put the -2 in brackets. Always be careful to note this. This minus sign is from the formula, and this x sub 1 is actually equal to -2. And since x sub 1 equals to -2, and there's one negativity before, we have to put that in the bracket. And so we can rewrite this as -13, -5 minus 8, -13, divided by 6 plus 2, because minus times minus is plus. This becomes 6 plus 2, okay? And almost finally, our m is equal to -13 divided by 8. We can leave our answer like this, but usually, since we've been taught from primary school that we don't leave our answers an improper fraction, let's change it to mixed number. This will give us -1 whole number 5/8. And this is the final answer. This is the gradient of the line joining these 2 points together. That is the slopiness. It is negative. It actually means that the line is going down from left to right. This is the way the line is going to look like. So that is how simple it is. Actually, more simple than it looks like. Thank you for joining us in today's lesson. Thank you for having your time, and I hope you join us next week. For further reading and reference, please select Coordinate Geometry of Straight Lines lesson content, available at learnathome.ng.